I am the environmental safety and health director for a large oil and gas company. And so that basically includes also leading all of our safety teams for our business, which also includes the engineers who facilitate our process safety programs. There's no short path. It's a lot of, when it's safety, it's really a lot of experience.
Hi, welcome to the Job Dictionary podcast. Today I'll be interviewing Bryan McMurray to learn about what it's like to work as a safety engineer. Uh, First off, Bryan, thank you so much for joining us today.
Hey, no
And
problem.
in your own words, what do you do?
I am the environmental safety and health director for a large oil and gas company. And so that basically includes also leading all of our safety teams for our business, which also includes our safety engineers who facilitate our process safety programs.
Awesome. When you were a kid, what did you want to be when you grew up?
When I was a kid, I thought I was going to be an electrical engineer. I really like drawing actually, and so I would get into making drawings of houses and schematics of just like little things that we build from Legos to different toys like that. And so it actually got me into drafting in high school back before computers. And so I always thought I was going to be in some kind of technical role, but you end up doing other things sometimes.
Right. And can you tell us where you're actually located?
Yeah, I work out of our Houston office in downtown, and I live in College Station, but I commute.
Okay. How long is that drive about?
It's 86 miles one way, so about an hour and a half, assuming no traffic.
Right.
But I like living away from town, so kind of self-torture, but it's worth it.
And how long have you been working in the oil and gas industry?
I've been in the oil and gas industry for about 9 years. Previous to that, in my career, I was working in heavy manufacturing straight out of college. So I worked in a sawmill, wood treating facility where we made railroad ties as a maintenance supervisor, basically leading the teams to oversee the maintenance of those facilities and including safety and health of those facilities. And then I went from there to steel manufacturing, basically leading different processes from melting scrap all the way to the finished product that goes into large commercial construction like high rises and things like that. And so I worked in various aspects of that job, from maintenance supervisor to environmental manager to safety um, coordinator, different roles.
Wow. That's awesome. And what made you want to get into this field, kind of?
It wasn't an active choice, a conscious choice. Basically, when I got out of college, I got my first job, and the company I worked for said, "Hey, we'll hire you for this position, but we need someone to lead our environmental and safety for our facility." And so, coming straight out of school, I had to kind of jump in head first and learn regulations, learn all the work practices, uh, learn history of injuries and things like that that happened in the field, in our production facilities. And kind of on a side note, at the same time, one of my good friends, who was a year behind me in the same degree path, which was I was manufacturing engineering technology at A&M. He was in the same degree path, and he was interning at a facility, uh, at a different facility, um, as a senior, and he was working as the intern. He ended up getting electrocuted, and he died
Oh,
in that process. So it kind of and that was right when I started my new job. So it really kind of jump started my enthusiasm about taking on my new role. Whereas before, I just thought it was something I was just going to have to do, and it made me take it much more seriously, realizing that the risks were real for everybody.
right. And can you just kind of elaborate on that learning curve and then the major learning you got out of seeing someone pass?
Yeah, you know, like I said, I started the role, and it's like, okay, I'm going to be in charge of safety for this facility, which they called it a environmental safety coordinator. It was kind of a dual role in addition to my supervisor duties. And I initially, like I said, I just took it as like I thought it was just some boxes I had to check, and I didn't really understand the inherent risk of what people did every day. Um, I knew things were dangerous, but you don't really, coming out of school, you don't really put the two together that, hey, this is real and these are real people and this could actually happen. Um, and so when you start getting into that, especially around safety, whether it's from the engineering design side or to, um, behaviors and people and the culture, uh, is a little bit overwhelming, I would say, if you is coming in new. Um, I wouldn't say that I was good at it for a long time. I would say the learning curve is really long, mostly because you can learn all the technical things, and you can learn all the regulations. You can go get certifications and know all the answers. But putting it into practice and learning how to work with the people, it takes a lot more time to do that. And
Right.
and I would
Um,
say even today, I'm still learning. I'm still getting better, and it's not something that you ever just say, "Okay, I'm a master of this."
is it more of a mental thing, you'd think, than it is like when you're in charge of all of these people? What is the weight of that?
I mean, it's I think that's the challenge of any leadership role is, a lot of people, you don't realize until you get into those roles the impact that you have on those around you. And whether you're leading safety or just operations in general, or a technical team, or a business team, um, the leadership side takes time to learn as well, right?
Right.
And you're not, I don't think there's a such thing as born leaders. There's people with great attitudes and do things well and work hard and have good work ethic, but you have to have those experiences with people to
Yeah.
learn how to be effective at it. And so, yeah, it's a burden as a leader to think about that, and that you may be responsible for someone directly, or over time you become responsible for just the culture or things that happen in a business. But I don't think that's necessarily specific to someone just in safety. It's that falls on everyone in leadership throughout the company, from the CEO all the way to the frontline supervisor.
That's a great point. And so kind of going off of that, what like comes easy to you, like in the safety engineering role and the leadership role? Um, and what advice would you have for people?
Yeah, I think having the engineering background and training, just taking a systematic approach to how you solve problems, and then trying to apply that to what might seem kind of nuanced. Hey, we're trying to influence behaviors, or we're trying to ensure that our systems are designed correctly. Sometimes it's really black and white, sometimes it's not. Um, it I kind of lost my train of thought there. So
Yeah.
taking those systematic approaches and applying them. So I think, from the design safety, it's really black and white. You have engineering standards that you have to follow, API standards,
Right.
regulations that you have to meet. So that becomes really easy, black and white check marks. And so that's probably the easiest part to apply to all of it. And then just learning to be social and enjoy being around people helps you do the other piece. So I think having those two, kind of key components of my personality and the things I like help me be successful in that role.
And kind of taking a step back, what did you study in college, and like all of the standards that there are, what degrees and certifications are truly required, you think, to like be good in this job and required for a safety engineer?
Yeah, so true safety engineers, you definitely need to have an engineering background, especially if you're in the design aspect of it, and even down the road to the compliance aspect, because you maintain the equipment over time. You have to make sure it still continues to meet the engineering standards that they were built to, or if there are new standards that come out, making sure that you are improving those systems to meet the new standards. So having an engineering background, whether it's in chemical engineering, mechanical engineering, or even electrical engineering, different roles like that those different kind of schools, I guess you would say, they can all help you be successful in a more general safety engineer role. Um, at the time when I was in school, they didn't offer a safety engineering program. I think there's more of those available now that help you kind of focus on applying those engineering skills to more of a safety problem. Um, but so thinking about that is, if you're going to go to school for these types of jobs, for specifically for a safety engineer, you would want to have an engineering degree, and then go on further than that. You'll want to join trade organizations like ASSP, Association of Safety Professionals, and then there's certifications you can get. Uh, Professional safety certifications, CSP, which is Certified Safety Professionals. You can get an introductory one. It's the ASP, Associate Safety Professional. Those help you kind of learn. Those basically demonstrate that you understand the regulations behind different aspects of safety regulations. Um,
How
and it
long
just
do
kind of helps you
those
show that you have kind of the baseline knowledge for some of the rules that you encounter, and some of the problems that you might encounter, whether it's exposures out in the field, employees being exposed to certain chemicals, and learning how to design those out or put work processes in place, all the way to um, training to the design itself. I think you would say, the safety engineers who focus just on our processes, they're in front of a computer a lot, and they're doing design, they're going through standards, they're auditing, they spend a lot of time auditing. So um, to me, it's more around management systems. And
right?
so I think that's partly what helped me as a manufacturing engineering technology. They really focus on utilizing management systems, Six Sigma concepts, and things like that to solve problems. And when you use management systems, which is kind of a generic term, but it's thinking about understanding all the different elements of all the problems you have to solve and coming up with standardized ways to solve those, and applying that to your job or whatever problem you're trying to solve, whatever scope of your job is, whether it's just one production unit or an entire facility or an entire division. Learning to use those management systems so that you can create baselines and measure your performance and continue to drive continuous improvement.
Right. Thank you for that. And going back on to like the degrees, specifically the certifications. Wow. How long does that timeline normally take to get through those?
Yeah. For the associate, um, for the ASP certification, I think you just have to have like 2 years of field experience. So if you come out of school and you go out into a field, um, and you start kind of learning whatever your business is, whether you're construction or manufacturing or um, a chemical plant, like just having I think there are minimum requirements you have to have 2 years. But then you can go in, and once you have that 2 year background, you can apply for the exam and then study for the exam and take it. So it doesn't take long to get that introductory ASP. Um, to get your CSP, it's more. I don't know off the top of my head. We'd have to look it up. Um, I don't, Me specifically, I don't have that certification, but for my teams, I challenged
Mhm.
them to get those certifications. Um, and again, a lot of those, it's not required for the job. It just helps when you're interviewing or when you're looking at your experience. It helps me um, kind of gauge the amount of experience they have. So I might look at someone with a 4 year degree with a certification and uh, and 4 years experience, and to me, they may have the same technical capability as somebody who spent 8 years in a field with no certifications or no degree. So it's just kind of, you learn different things different ways. Um, a lot of people on my teams don't have any degrees, but they're not doing process design safety. They're doing more people oriented safety, where you're going to influence behaviors. But if you're doing true engineering, you have to have those degrees to be able to do that and to be able to sign off on different things.
Right. Um, and I guess if someone wanted to take a non-traditional route, to get into on your leadership team into safety engineering role, how would that look?
If you're going to do the non-traditional route, which I would say just like starting out from the ground up, um, I think the key is to get involved with whatever job that you're doing and start asking questions about the different safety aspects and designs and roles that you have in that particular job that you're in, and get experience with your industry, because any of the safety engineering or safety jobs that are out there, they're all going to be very industry specific. So the more you can learn about your industry and what it means to be safe in that industry and what are the requirements from a behavior standpoint or from a design standpoint, those will help you get going. As you kind of move up, you're going to want to get continuing education um, one way or the other, so that you can learn the technical aspect. And and you'll see people as they progress through their careers, they get um, you know, people find the place they're happy at, and so
Right.
some people stop at just doing day to day interactions with people and influencing, almost like a coach. So you don't need as much of a technical degree on that side, but if you want to, like I said before, if you want to move all the way into designs and things like that, you're going to have to go back to school at some point to get to get an engineering degree or some other technical degree, so that you have the technical basis for promotion. I think at the end of the day, it's always possible to move up without the degrees. It's just going to be harder, and there's going to be a ceiling that you run up against sometimes, especially with some corporations. It's going to be a minimum requirement that you have a 4-year degree, but not always. But especially for your big companies, your big Fortune 500 companies, the S&P 500 companies, they're going to have higher thresholds that you have to meet to make the promotion. We typically, we have a career ladder, so we'll outline everything from basically a new hire specialist who doesn't have any background to get
Right.
to a tiered progression all the way to what we would call an advisor. So you would, there's like 7 or 8 iterations you can use to progress up to that senior level, which may take 20 years to get to that final level to have that much experience. But all along the way, there's different experience you need to gain, different project success you're going to need to gain. Um, Getting additional education will help accelerate that. But there's no short path.
Right.
It's a lot of, when it's safety, it's really a lot of experience. It's not a math problem. It's a math problem, but it's not always a math problem.
Right. Because you're dealing with real people in their lives and
Yeah.
things like that. And so if you were talking to a third grader, what specific tasks do you spend the majority of your day working in like layman's terms?
Well, thinking about it from a engineering standpoint, you're spending most of your time making sure everything is still the way it was intended to be. So if you're talking about a third grader, it's like if you look in your room and we have our desk in a certain place in a classroom in a walkway, and we want to make sure everyone keeps the walkway clear so we don't trip and fall. And we tell everyone to hang their backpacks on the hook so they're not on the floor that we trip on. Like
Right.
those are things that we want to keep doing all the time. And so that's what most of your safety folks out in the field spend all their time making sure everyone has their backpacks put away and they pick up their things off the floor, and that they're following the rules that are in place, so that things aren't broken and create an unsafe environment.
Thank you. And what part of your job specifically is like most exciting and interesting to you?
I find the most exciting thing to be when we work on big projects to make things different that have a change across the entire company. So I use an example, motor vehicle safety, which people don't think a lot about that a lot from an engineering standpoint, um, because you kind of leave that up to the car manufacturers. But a lot of our teams have to travel and go from site to site, and so it ends up being that many of our injuries and our most serious injuries end up being driving related. So you think about how do we solve those problems outside of just trying to influence behaviors, like stay off your phone, don't be texting while you're driving so you're not rear-ending someone or you get distracted and pull out in front of someone. So then we find software tools and other things like what are on, they come standard on some phones to be able to turn your phone off so you're not distracted. But we put we add monitoring devices to our vehicles to help monitor people's driving behaviors, and we use that technology to give feedback and coaching to the people who are driving for our companies. And then we also use software technology to basically force people to set their phones down. And when you do things like that, you see our what we call our preventable accidents. Those preventable accident rates have dropped significantly as a result of those technical engineering solutions that we put in the vehicles, which drive
That's a
behaviors.
great point. And I feel like I kind of take that for granted when I'm driving
Yeah.
because you know what I mean. Uh, it's this vehicle, and you just get so comfortable using it, and then it's easy to get distracted and stuff. So
Yeah.
that is super impactful. And kind of like on the latter side, what parts of the job are like the most challenging emotionally and like day to day?
Yeah. There's probably the two things that are the most challenging, probably hard to deal with is going to be the pressure that comes with when something goes wrong. So, ignoring injuries and that type of thing. If you have in a chemical plant, for example, if you have a major leak or a fire, um, and then you were the one that kind of led the design at that facility or the oversight, or even support of the operating procedures and practices that we have in place to continue to keep that place working safely, you're instantaneously you're thrown into, I have to go figure out what went wrong and help
Right.
support the investigation and figure out how we can prevent that from happening again. And so that can get stressful. And then what happens is often you have regulatory bodies come in behind you and who will start investigating behind you and second guessing your work. That can be stressful, especially dealing with the enforcement agencies, whether it's the EPA or OSHA or the state agencies. Um, and then the other side of it is the actual, the people when they get hurt and or if you lose people in a fatality and those people that can be the injury or fatality itself can be emotionally challenging, but then you may be the one who's responsible for doing the investigation and get into the details of what went wrong and was it a design issue, was it an operating process procedural issue, was it a behavior issue, and trying to find those with that burden of you may have even known that person that was injured or
Yeah.
seriously hurt.
What are some things that you do to like combat that high level stress of caring for so many people?
I think just maintaining your professional friendships with everyone and maintaining a positive attitude. It's easy, especially in a compliance or technical role, to just be work all the time, straight to the book. We got to do it
Right.
this way. But just learning to enjoy yourself and have fun with your teams that you work with, and realize that everyone's people. And to me, having those, especially from a leadership role, making sure we pull people out of the workplace and go do things that are fun. Go hit golf balls or go
Right.
to the different events you can do as teams. That's probably one of the best things you do, at least in the work environment. And then at home, and just relax. I try to turn it off
Right.
when I get home.
It's awesome. And it's hard, but I think that you are able to manage it very well. Um, and so like talking about the parts of your job and the fun stuff, but what is just like the most boring, mundane parts of your job, you think?
It, it's probably what we call a process hazard analysis (PHA). So it's this very long, drawn out process where you go through a processing facility like a chemical plant or a gas processing facility, and you go through every single step of the operating process from every
Wow.
node, so from the product to the time it comes inside the plant to the time it leaves the plant. You go through every single step, every single alarm, every single measurement, and you spend days and days and days going through
Wow.
all that with a big team. You have mechanical engineers, electrical engineers, you have operating supervisors, you have the actual operators, and you're all in there going through that. And you have to do that by regulation. We have to do that every 5 years at every
Wow.
facility, and you have to do that before you start up a facility. And so, I don't think that's fun sitting in those rooms for a long time. But when you get done, it feels great because you've gone through your entire process and you understand all the controls, and it's a good learning experience for someone who doesn't understand what's happening in facilities. So we often bring people into those, even though they're kind of boring. It's a great way to learn all the details about the controls of your process.
Are those opportunities as well to meet different engineers from like different backgrounds?
Yeah, and that's kind of the nature of doing those is we want a diverse group of people in there who think from different
Right.
perspectives. You the electrical engineers are in there, they're looking at your control systems and your measurement devices, and you have mechanical engineers that are in there looking at your pipeware and your pressure vessels and the operating pressures of those things. And you have safety uh, engineers are in there trying to make sure we're meeting all the required standards for operating those facilities. And you'll have just safety professionals in general who are thinking about the operators um, and the procedures they're following and the things that get them distracted so that maybe they would make a mistake and then that would lead to some kind of mechanical failure, which might in turn lead to something worse. So it's neat to have everybody in the room with all those backgrounds to all kind of stack hands to solve a bigger problem.
Yeah. Um, and so now we're gonna get into some rapid fire questions. Thank you
Okay,
so much for all of your insights as well. Um, so what is a day in the life of Bryan McMurray in the terms of wake up, startup time, and then like breaks during your day?
normally I get up around 4:30 or 5 every morning. And I have a family here at the house and try to make sure everybody's up and they have all their directions and where they're going that day, and get a plan for the rest of the day, knowing that I'm about to get on the road and I'll be several hours away until tonight. And so I get up, have a protein shake, make a coffee, and I'm usually on the road by no later than 6 or 6:30, and that puts me in the office by 7:30 or 8. And then once I get into the office, if I'm in our corporate office, I come in, I'll go through my agenda for the day, what meetings do I have, what teams am I meeting with, do I have any major fires that I got to put out, enforcement or somebody got hurt over the last day or so, and to kind of line out my day. And then from there, I basically bounce from meeting to meeting, and then uh, and we say meetings, people kind of they nuance those as like, oh, it's just a meeting. I would say most of the meetings that I'm in, you're solving a problem.
Right.
So it's fun. So you get it, you're sitting down with a team of people and you're talking about the issue or the challenge that we have and figuring out what resources you need and who's the best people to put on those resources, or you're checking in with a team that you assign to something and getting their feedback on what how their success is going or not going, and you just try to make adjustments and encourage people and give them the right resources. And that's the whole day. Breaks. Sometimes I'll take a lunch break. Most of the time, I'll just eat in my office. If I'm out in the field, you take your teams out to lunch and things like that. If I'm at the plant or at a pipeline or something like that, you just kind of make it work. Um, I try to take time to go to the gym. Sometimes I can
Right.
pull that off at lunch break. Other times I have to do that early in the morning. It just depends on what happens. And then around 4:30 or 5 every day, I start packing up and I head home. Home at 6:30 or 7. And then
Your
the
hour and a
family,
half drive
yeah.
home.
My wife always makes fun of me because I'm there all day, kind of, you know, I, I would say my leadership style is kind of direct.
Right.
Um, and that's the feedback I get from my teams. And when they first meet me, it's something I try to work on. Is they tell me it kind of scares them, I guess, because I'm so direct about what we're going to do and how we're going to do it, and then I want to hear what they have to say about it. And so when I get home, I'm still in that. Hey, this is what we should do. This is how we should do it. Tell me how you think we should do it. And I'm asking a lot of questions, or tell me what's going on here so we can figure out what we need to do. And my wife's like, "Hey, you're not at work anymore. You're not in charge. You got to step back." So it's a transition that I have to do on the drive home to make sure I change my mindset when I get home. I'm just a team member when I get to the house. I'm not in charge.
Um, and so like kind of hitting off of that, I know you said that you work in teams a lot.
Mhm.
How much is that is and you hold a leadership role? How much are you in meetings compared to like your solo working time? And how would that be different kind of when you're first starting out to when you like get a leadership role?
Yeah, I think that's a good question. I'd say currently I would probably spend 75% of my time in a team environment. the 25% I'm using to plan and come up with plans strategically, kind of thinking long term. I try to plan 1 to 3 years out for all of my teams when we think
Yeah.
about goals and where we want to be and what issues we have. And so using kind of those high level plans, then I spend the rest of the time working those teams to come up with action plans and basically our to-do list of what we're going to do to meet the goals we have or to meet just our day-to-day requirements, right?
Right.
So I would say that's now in my leadership role now. It's straight out of school. Even though I was in a leadership role as a supervisor, I would spend 85% of my time working on my own because you're writing procedures or you're doing inspections or um, you're taking classes, you're having to learn. It You spend a lot more time trying to figure out what you are and solving a specific problem yourself that you've been tasked with. To as you can move through your career, you're less task oriented and you're more strategy oriented. I guess that's the biggest change.
That makes a lot of sense. And then, so like, how flexible is the industry in hours and remote hybrid work? Or is it more like set in stone of we have to be at these meetings at this time? And what does that look like?
It really depends on where you work. I mean, clearly, I'm working remote today in my home office, it's a really unique situation, especially in our industry. I would say most people don't have that opportunity, and it's just one of the perks of working in the specific office that I work in that I can have the occasional opportunity to work remotely. Um, and that's the only reason it works is because I'm in the leadership role and I'm not the one
Right.
putting my hands on things. I would say from a safety engineering standpoint, it's almost exclusively you got to be on the ground. You got to be talking to the teams out in the field. You have to understand the operations. You have to be part of the operation. And so I spent most of my career working alongside traditional, blue collar workers, welders, um, tradesmen, uh, operators, and they all start work at 7 a.m. So and
Right.
they work 7 to 3:30 traditionally, especially if you're working shift work, 7 to 3:30, 3:30 to midnight, midnight to 7, things like that. So you're trying to catch shift changes when you first come in, so you can talk to both teams, all three teams if you're working around the clock. So that being said, most of you're going to spend most of your time at on the ground, and you're not going to be working remote.
Right.
The, the opportunities come up, especially if you're more on the engineering design side, you have the opportunity, to spend time, uh, if you're doing audits or things like that, you can do some of that remote. But we found even after COVID, we let people do remote work, and it just doesn't work in our work environment because for two reasons. You're not there with the people who have to be there every day no matter what because they have to touch a dial or control a unit or go do a physical inspection or hook up a hose. They're there no matter what. And that's going to be, if our company, I think there's 3,200 people in our company, you know, 2,800 of those 3,200 are doing that, right? And then
Right.
if the other 400 of us never came to work, we wouldn't add any value. So there's a big difference
Yeah.
between working in what I would say heavy industry versus a business office type job. They don't overlap very well.
That makes a lot of sense, especially in the realm of safety engineering. Um, you kind of mentioned some tools and technologies that y'all use, but could you expand on that?
I mean, there's lots of different tools and technologies. It just depends on what it is that your specific job is, right? So if you're a process safety engineer, for example, you're going to have a set of audit tools that you may use, which is software based on your computer that you use to track your checklist and your inspection
Mm.
points and measurements and things like that. You're going to have all that tracked in proprietary software or something off the shelf that the company's bought. There may be there's a lot of databases that type of software. If you're doing inspections and you're doing measurements on thickness of pipe, and you got to take a measurement every 3 feet or every 6 feet,
Right.
and there's tens of thousands of even miles of pipe in one facility, right? So you're gonna have all kinds of data points. So you have really detailed, specific software packages that help you track the mechanical integrity of your processes. You have investigation tools that we use, whether they're conceptual. One of the things, when you have problems and failures, you have to do a failure analysis. And so one of the things that there's different methodologies you can use to get to that root cause, or some people like call them the root cause, or just finding the causes of whatever your failure was. So you learn those different methodologies, and then there's software packages that help you track and facilitate the use of those methodologies. I will say that in my career, not my biggest mistake, but the biggest mistakes I see is leadership trying to implement technology before the work process exists, especially from a safety engineering standpoint. So the idea that, if we have a lot of failures for certain types of rotating equipment like pumps or compressors or something like that, if you're having a lot of issues with that, and they're like, well, if you buy this software package and you start using the software package, your maintenance is going to get better. Well, the reality of it is, unless you actually do the maintenance and you have a schedule that you follow, even if you can't write it down on a piece of paper, the software is not going to solve your problem. And if you don't have the work processes with your teams to make sure that you have schedules in place, you're doing the required maintenance or you're doing the required inspections, and you don't have those work processes and approvals for doing the procedure changes and approvals of procedure changes. If those work processes don't exist, like virtually, and then having those flows, process flows written on a piece of paper, the technology will never solve that for you. And so the company can end up spending millions of dollars trying to implement a software or some technology to solve a problem, and it will fail because they didn't have the work processes to begin with.
That makes a lot of sense, and I feel like it's something that a lot of people will kind of overlook too. They don't think about the both sides to it, I guess.
Yeah. I think I
And
probably spent more times in team meetings explaining to someone that that's not going to work until you've fixed your work process.
until you make it simple and put it down on a piece of paper
If
too.
you can't draw it on a piece of paper for me, what's going to happen when I submit this piece of paper to you and say, we should go from here to this person, to this person, to this person, and then this problem gets solved. It's like, trying to think of an analogy. It's like if you have a computer and you get Microsoft Word, buying the software and trying is not going to make your paper get written. You have to learn how to write a paper before the paper gets written. So
Right. That makes a lot of sense. Thank you. And lastly, for the rapid fire, what do you wear to work?
that depends on where I go. So if I'm in the office, we have kind of a slimmed down dress code. So we wear jeans and a polo. That's the minimum requirements. Nice shoes. You'll typically see me. I'll wear a button up and a sports coat when I'm in the office, just because I like that. That's just kind of my style. If I'm in the field, we're wearing FRs, fire retardant. FR stands for fire retardant clothing, and so those are rated for different situations, whether it's a fire or an arc flash from electrical arc, and steel-toed boots and hard hats and gloves and safety glasses and ear protection. So if I'm out in the plant or at a pump station or on a pipeline, that's what I'm going to be wearing. And,
do you normally keep that in the back of your car too, or?
Yeah, I keep a hard hat in my office because I'm ready to go at any time. And
That's awesome.
You got to be able to go everywhere. I have probably several pairs of steel-toed boots in my closet and one pair in my truck. And so, and I do that on purpose because if I'm in the office and something's going wrong, and particularly if we have a major incident or a major pipeline leak, it's not like this is something you snap your fingers and goes away. It requires a full coordinated response. You're going to be meeting with emergency responders on the ground, with the community, which is another aspect of what we do. We have to plan ahead of time with all of our emergency responders. So we spend a lot of time meeting with them and walking them through our processes and teaching them what it is that we do. So if something does go wrong, they don't put themselves in danger trying to respond to what they perceive is something they have to fix. And so, for example, in a pipeline fire or a pipeline release, you don't want the volunteer fire department showing up trying to put that fire out. They don't understand what that is until you kind of explain it to them. Um, and so even to the point we at Texas A&M, they have the fire school there. So
Right.
we have fire brigades at some of our facilities. So we bring them up here, or train our operators to be industrial firefighters. And where I'm getting with this is we also work with the local firefighters within the cities. And so we'll bring some of the actual firefighters from the first responders within the community to come train with us. And so, like this week, they were up here at the fire school training, and so the local fire department was also here training with us, so they could learn how to support us if we had something go wrong in one of their facilities.
That's super cool. Um, and I guess moving on, what do people underestimate about this profession, you believe?
Uh, I think they underestimate the amount of planning and coordination. That's probably the biggest piece. The amount of planning and coordination it takes to be successful. It's I think as you kind of go through college, you're used to you get a problem that's written on a piece of paper, and you learn whatever pattern it is to solve that differential equation or uh, you know physics problem. And so it's like you learn how to do a package response to that, and you know that it gets there. But when you're planning in real world, it's never just a problem that you can just instantaneously solve. It's like you got to think about it ahead of time and know that you're probably not going to know what actually went wrong. And so every resource that is out there to help respond to that problem or to correct a failure or to create an improvement, it requires long-term planning and training and getting the right teams and technologies in places. Um, and then outside of all of that is the regulatory piece that's behind it. I probably spend at least 30 to 40% of my time dealing with regulators, whether it's the EPA or the state, TCQ, OSHA, and not because it's kind of like a necessary evil. They
Right.
drive our national standards, right, and why we do certain things. But when things go wrong, they have a duty to come and enter, get involved. And so that can be quite overwhelming. And if you're not used to that, or if you don't understand how those relationships work, it's something that not everybody can handle.
Right. And so, like, I guess from what you're saying, someone who can like focus on a lot of moving parts at once and um, be really good at that is someone who would excel as a safety engineer.
Right. Yeah, I think you have to be able to multitask. You have to be organized. You have to have some tools in your daily routines. And I teach that a lot to my teams. It's like you have to create a work routine. Whether it's what you do, come in every day to think about what you got to get done that day, how you track your projects, how do you track what tasks you need to get done, who do you need to speak with. You have to be extremely organized to keep up with all the moving parts, especially if you're working across multiple locations. Any one of our safety engineers might be responsible for 20 or 30 locations, and
Oh,
hundreds of people that are involved in those locations. And so you have all this information coming at you all the time. And if you're not able to process all that information in organized ways so you can systematically go through it, you'll fall behind and you'll struggle.
that's a great point. And I guess kind of hitting off that, what do people overestimate about this job?
Yeah,
Or can you
I,
even overestimate anything about
I
this
think they
job? Because
overestimate. Like a good example is one time I was in the role that I'm in now. I think people were complaining about people driving too fast in the parking garage. Just something really simple like that. And
right.
it's like the idea is like, hey, just call Brian and he'll fix that. Like so, you talk about safety engineering or any problem. It's not something that a safety person can just fix. It's
Yeah.
we are there to influence and create solutions to problems that exist. But we're not. People a lot of times they kind of look, because we deal with regulators. They tend to see the safety support as almost like cops or police within the workforce, and some professional safety professionals try to act that way too, but it's not what we are, and that's not what we do, and so it's really important that uh, when you're working as a safety professional, whether you're on the engineer side or the behavior side, that you're teaching people that you're there to support them and what they do. You're not
Right.
you're not the enforcer. You're
Yeah.
just there
And
to
not the
help
end all
solve the
be all
yeah.
kind
You're
of
just there
thing
to
as
help
well.
solve the problem and help
Yeah.
them find solutions to the problem that they have. And it's kind of a nuance of being in a support role versus a person that's actually running the operation.
That makes a lot of sense. And I know you said that this is like an ongoing learning job and it comes with its own problems, but like how long does it usually take for someone to get really good at this job? And how long did it take you to kind of be like confident in knowing what you're doing?
Yeah, I would say when I look at safety professionals, I don't think you really feel confident until you've been maybe 5 or 8 years. You start to feel pretty confident in your business and what you do. Just from being green to not knowing anything, it would take 5 to 8 years for people, I would say, really say, oh, he knows what he's doing or she
Right.
knows what she's doing. Um, but I think we all kind of, as that happens, you get really good at that role and then you get promoted or move into a different role. So then you got to solve that problem all over again, right?
Yeah.
But it's, being a safety engineer or safety professional in general, it is a life, and it is a career. That's something you can do the rest of your life, and you'll continually get better. Some of our best resources that I rely on out in the field, and those guys have been working in these facilities, 30, 40 years. And those experience,
Yeah.
and the reason they're so good is because they've experienced the things that go wrong. And that's
Yeah.
really a safety engineer. You're there to prevent things from going wrong, but when things do go wrong, you're there to figure out how to solve that. And so the next time you're able to get ahead of it, and it just takes experience to learn all the different
Right.
nuances of that. But if you're coming out of college, I'd say in 3 years you might be able to start looking for your next job because you've got 3 years under your belt, or
Right.
be looking for that promotion, and then 5 to 8 years you might find a leadership role. um, that's typically what I see.
What is the highest position you can hold? And then like I know you kind of talked about the promotion path, but what is the average time spent at each level? Is it like the 3 years and then after 3 years go and hold a leadership role for 5 to 8? And I guess what does the end look like?
Yeah, if you think of it from an individual contributor standpoint, um, I would say on average, kind of moving up to each level is like 3 to 5 years. Some people can do it
Okay.
faster. I've seen people move up very quickly. 18 months, they accelerate. They they understand what's happening. They really fit in well, and they can really understand how to solve problems. And other people are, it might take them 8 years to make that same jump. But um, you know, it's I would say that's probably typically what you would see is that 3 to 5 years in between each transition to from a entry level specialist to a senior specialist to um, you know call a staff specialist, someone that's been on staff for a long time. They got 10 plus years experience.
Right. Could you, even if it's super broad, kind of explain the average salary for someone at your level or someone who's starting out?
I think this day and age, I mean, when I came out of college in 2000, right? Like I
Right.
was really excited to get $45,000 a year. That was a
Yeah.
big job, and that would be. I don't think if you got that today as an engineer, you would be really disappointed. I think, but I think you're going to see anywhere from maybe 60 to 75 coming out of college in an
Okay.
engineering role, and just me just kind of guessing. I don't I'm not HR, so I don't have all the salary brackets. But I just kind of know
Right.
what I see people kind of getting into. And then that's starting out. And then on the high end, depending on from an individual contributor standpoint, not getting into leadership is, an individual contributor. You could get up to, 150 at some
Right.
point.
Wow. Well, thank you for that range.
Yeah.
And so when people in your field move on, if they do move on, I know you said it is a really good career, but what would they go into next? And is there any like themes of people who springboard into anything?
Yeah. When people leave the company, they usually do it for several reasons. One, they get a great promotion opportunity doing the same type of job somewhere else, maybe in a leadership role. or maybe a higher leadership role than what they ever have. They already have. That's probably the primary thing that you see when someone leaves because there was an opportunity that came up somewhere else that they didn't have, that just didn't exist within the company. Not because we didn't want to create that for them. There's just only so many jobs and so many opportunities to move up. But uh, if they leave the industry or they leave it altogether, a lot of times you get in, especially if you want to be like an entrepreneur, the consulting is a huge place to go. And I would even say if you're not sure, now that I'm thinking about it, if you're not even sure that this is the type of job you want to get into long term, that's a great place to look straight out of college is to go work for a consulting company who consults in safety engineering. Because you kind of
That's
get
great
rapid fire,
advice.
you learn everything, you're out supporting other companies doing exactly what you might be doing for them later, and you do it
Right.
quickly. And you may just have a small role, but it gives you a lot of exposure quickly. Um, that or working straight out of college, that or working for one of the agencies. They tend to hire anybody they can get to come out there because it's just because they don't have as high of a pay, so it's harder to get. They tend to hire younger people in the agencies. Um, but then down the road, you see people move into back into consulting roles, senior consulting roles after they leave industry. They go work for a big consultant, run projects, or they start their own business as a consultant something very specific that they like to do, whether it's process safety design or maybe they like training or maybe they just like doing compliance and so they put programs and they like working with companies to build their compliance programs. And so just it kind of depends on where you want to go. If and then I've seen guys just completely leave and go start a honey business, so it just
Right.
depends on what you want to do.
So yeah, it's kind of like a place where you can establish your network and springboard into really any industry and
Yeah.
use that knowledge of safety and caring about people and can kind of move you into anything.
Hmm.
Is that
Yeah, I think
okay?
that's it. It you don't get pigeonholed in this industry because it's so
Right.
broad and there's so few people that are really good at it. So it we're always, not always, but we hire pretty regularly, and there's the pool in the safety engineering is that with especially people with experience is not very big. It's hard to
Right.
find people who are looking for a job or not happy where they're at to come work uh, in that role. So it's kind of a niche in that standpoint, but once you get into that niche, you can go work almost anywhere. Like I mentioned earlier, like I made railroad ties, we made steel, I was
Right.
involved in construction, and now I'm in oil and gas. And I've had kind of the same general responsibilities at all of them when I was in the safety roles. Um, but I went back and forth too. So, I started out as a maintenance supervisor. I've been a plant manager before. Um, I've been an environmental manager before for a facility. I've been a regional environmental safety manager. So it just depends on where you want to be. And so you can kind of move around. I would say that if you want to be from a safety standpoint, people with actual experience within the operations of the place that you're supporting tend to
Hmm.
do better. So if you have the ability to get into a safety role and then move into an operational role and train with them for a while and work in one of those roles and then maybe move into um, maybe a commercial role or something where you're getting on the contract side. So you kind of learn all aspects of the business and you come back, you're much more rounded to be able to lead safety from that perspective.
That's really great insight. And kind of just wrapping up, if you could tell your younger self anything when you were getting started into this position, what would it be?
Save all your money.
One.
Advice.
One.
Um,
Save all your money.
Save all your 401k. Put everything in it. I would say, um, just set yourself up as fast as you can to do that. But then from a technical standpoint, I think going back, listen more. I would listen more. You know, I've been accused of being arrogant sometimes because I think I know everything, right? I think a lot of engineers are that way.
Right.
But just understanding that there's a lot to learn from people and learning to be more willing to rely on other people to help you solve a problem and not trying to do it all yourself. That's probably what I would change.
That is something I think we're all constantly working on as engineers.
Yeah.
And I guess what like books, resources, programs, or anything would you like suggest to someone just kind of off the top of your head? I know you mentioned some certificates earlier, but
Yeah, if you're really interested in safety engineering, look into the American Society of Safety Professionals. They used to be called the American Society of Safety Engineers, actually, but they've broadened it because safety is more than just design; it's
right.
behavior and stuff too. But I would look into that organization, ASSP.org. That's a non-paid promotion, but they're a great organization to network with and meet other people, job opportunities, and they have tons and tons of resources that you have access to, uh, from technical guidelines to training and continuing education that you can from a safety role, kind of either get started or continue to grow yourself as a safety engineer.
Awesome. Thank you so much, Brian. And before we kind of sign off here, where can people contact you if they're interested in contacting or learning more about this profession?
Yeah, I'd be happy to speak to anybody. I would say just send me an email. It's Bryan, Bryan, at McMurray, McMurray.us. And that would be another thing. Go
Awesome.
back and buy your domain as soon as you can. I bought my domain in college, so
Me too. So we're up.
yeah.
Thank you so much for joining us today on the Job Dictionary podcast. It has been so awesome talking to you.
Hey, appreciate it, dude. Thanks.
You just got one episode closer to learning about the world of jobs out there. To explore the rest of our career categories and find your best fit, go to jobdictionary.com to sign up for the beta users waitlist. Then subscribe here to find the next episodes coming out this week. And as always, drop us a comment, review, or message to let us know how we could better attune our episodes to your specific needs. Follow us on TikTok, Instagram, Facebook, LinkedIn, X, Threads, Pinterest, and wherever else you're on socials to go get our short, snappy preview reels that expose you to new job options every day. Because here at Job Dictionary, we believe your big aha moment can be just one scroll away. Go check it out and get out there. Cheers!